Okay, so in the last video, what we did was we solved this non-homogeneous equation using the method of undetermined coefficients, right? So I'm going to borrow some of that same work that we did. Now we're going to solve this using the variation of parameters, though. Okay, so our first step is still the same. You get the characteristic equation, you find the roots of the characteristic equation, you say what y1 and y2 are. And now I don't care which one you call y1 and which one you call y2, but once you establish an order, right, you have to stick with that order through the entire problem. So for me, I called my y1 cosine of 5x, my y2 sine of 5x, and I'm going to stick with that. Okay. Now we're going to try to find the particular solution. Okay. So in step 2 over here, right, the form of the particular solution for variation of parameters is always the same. It's u1 of x times y1 of x plus u2 of x times y2 of x, where u1 is given by this formula. All right, maybe I'll clean it up a little bit here. I didn't have to cancel that part out just yet. There we go. Is negative f of x times y2 of x, right? Divided by a2 of x times y1 of x, y2 prime, minus y1 prime times y2 of x, right? So I'll make a quick note here, right? This a2 of x, right? This a2 of x right here, right? That comes from the coefficient on y double prime, which in this case is just 1. So our a2 of x is just 1, okay? So just keep that in mind as we go through the problem. Something else to keep in mind is that our denominators for u1 and u2 over here are exactly the same denominators. Our numerators look almost the same, except that my numerator for u1 is negative f of x times y2 of x. My numerator for u2 is f of x times y1 of x. Okay. So now, right, in order to use these formulas, I'm going to need y1 prime and y2 prime. So I went ahead and took the derivatives here. Right, we got negative 5 sine of 5x, we got 5 cosine of 5x, and then now I'm going to go ahead and compute this. Something that may help you out is to go ahead and compute what's in the parentheses here first, right? So just maybe as a little aside over here, all right, we'll have y1 of x times y2 prime of x minus y1 prime of x times y2 of x. Just go ahead and plug this in, right? Our y1 of x is cosine of 5x, right? Times our y2 prime of x. Let me kind of zoom in a little bit here. Our y2 prime of x is 5 times cosine of 5x, okay? Minus, now our y1 prime is negative 5 sine of 5x times our y2 of x is just sine of 5x. So we multiply all these out and we get a 5 times a cosine squared of 5x plus a 5 sine squared of 5x, right? We can, of course, factor the 5 out and we get cosine squared of 5x plus sine squared of 5x, which by our Pythagorean identities is just 5 times 1, which is 5, right? Okay, so what is our Pythagorean identity? Well, maybe I'll do a little aside over here. Okay, so Pythagorean identity. I'll just say p-ident. Okay, that's cosine squared of theta plus sine squared of theta is always equal to 1 for any theta that we plug in. Okay. All right, so that's going to be what's in my denominator right over there. So my a2 of x is 1, and then I have that this is just going to be 5 over there. So that makes my u1 and my u2 formulas just a little bit nicer. Okay. All right, let's kind of scroll over a little bit here. So my u1 is supposed to be equal to the integral. Upstairs, I'm going to have a negative f of x, right? So my f of x, I got to scroll up a little bit. My f of x was x cosine of 5x, okay? Times my y2 of x, which was sine of 5x, okay? All divided by, well, my a2 of x was 1, and then I had my y1, y2 prime minus y1 prime, y2 is 5. So there's my denominator right there. Okay. So I can factor out that 1/5. I can factor out the negative sign up front as well. And I can also do another trigonometric identity. So maybe I'll do a little aside over here. Okay. So in this aside, we're going to have a double angle identity. Sine of 2 theta is the same thing as 2 sine of theta times cosine of theta. Okay. There's also a double angle identity for cosine. So cosine of 2 theta, there's 3 different forms of it, but I'm going to write it as 2 cosine squared of theta minus 1. Okay, so just in case we need that later. Okay, so we're going to go ahead and integrate this thing, right? I'm going to pull the negative 1/5 out. Okay, oops, that looks a little bit crammed over there. I'm going to pull the negative 1/5 out here. Integral of, well, we have an x right there, and we have a cosine of theta times a sine of theta, right? So cosine of theta times sine of theta would be half of sine of 2 theta. So then this would be 1/2 x sine of 10x instead. That's 2 times 5x on the inside. Okay, that's using my double angle identity. Oh, and I don't have a denominator here, so I guess I could have made this a little bit bigger. 1/2 x sine of 10x. Okay. And then now you could use your double angle identity to get back to where we were, right? So we could factor a 2 out of this, and that would be sine of 5x times cosine of 5x times 2, and that would cancel out the 1/2 out front. So good. Okay. So then now this is just negative 1/10 the integral of x sine of 10x. Okay. So this is definitely something that we're going to have to use integration by parts on. I like to use the tabular method, right? So my u's go here, my dv dx's go here. My u is just going to be the polynomial, which is x, take derivatives until I get to 0. My dv dx is going to be sine of 10x. Okay, and then I'm going to take the integral of that one time, and I get that this is negative 1/10 cosine of 10x. Okay, take the integral of that again, and I'm going to get that this is negative 1/100 sine of 10x. Okay. Now, I'm going to take my x and multiply it by this. I'm going to add that term. I'm going to take my 1 and multiply it by this and subtract that term. And then I have the integral of 0 times this, so I'm going to add that term. So this is going to be a negative 1/10 times, well, let's see, I get a negative 1/10 x cosine of 10x. Okay. And then I'm going to get a plus, right, minus a negative. So plus 1/100 sine of 10x. Okay. And then we're going to get plus integral of 0 is just a constant, right? In this case, we can let that constant be equal to 0 because it would just apply to another homogeneous solution. So this would just be equal to 1/100 x cosine of 10x plus, minus 1/1000 sine of 10x. Okay. And that's going to be my u1. Okay. Now we'll go ahead and do my u2, right? And that's going to be the integral of, now I don't have a negative sign upstairs, so we're just going to have f of x, right? And then that's going to be multiplied by my y1 of x, which is cosine of 5x. Okay. And this is all divided by 5 still. Okay. So I could factor the 5 out. So we get 1/5 integral of x cosine squared of 5x. Ooh, okay. So now we're going to need another trigonometric identity here called the power reducing identity. Power reducing identity. All right, it's a little aside over here. Okay, so the power reducing identity for cosine squared says that cosine squared of theta is equal to 1/2 times 1 plus cosine of 2 theta. Okay, so then this is just going to be equal to 1/5 times the integral of, I'll apply this identity, so I'm going to have a 1/2 times x times 1 plus cosine of 2 theta dx. Okay, now I can integrate this thing, right? So I'm going to have that this is, factor the 1/2 out, so this is 1/10 times the integral of, I'll distribute the x plus x cosine of 2 theta, okay, dx, okay. So I'm going to get that this is 1/10 x squared over 2, so maybe I'll write this as negative 1/20. Oops. Oh, sorry, not negative 1/20, 1/20 x squared, right? Plus the integral, or 1/10, the integral of x cosine of 2 theta dx. Okay, so now I got to use integration by parts to find out the integral of x cosine of 2 theta. Okay, and right, I did x sine of 2 theta above, so I can't reuse that. Okay, so then now, right, Here's my u, here's my dv dx. Okay, so my u is going to be, again, the polynomial part. Take derivatives till I get to 0, right? Dv dx is going to be cosine of 2. Oh, I put theta in there. My mistake. My theta is 5x, so I should have had a 10x in here. My bad, everybody. Okay, so go ahead, erase that. That's 10x. Okay, and this is a 10x in there. Okay, so then inside of here, I should have had a 10x also. Okay, that should fix it. I'm going to take the integral of this, and I'm going to get a 1/10 sine of 10x. I take the integral again, and I get a negative 1 over 100 cosine of 10x. Take this times this with a plus sign, this times this with a minus sign, backwards, arrow, plus. Okay. So then this is going to be a 1 over 20 x squared plus a 1 over 10 times, this integral comes out to be a 1/10 x sine of 10x. Okay. And then minus a negative, so it's going to be plus a 1 over 100 cosine of 10x. And then plus arbitrary constant term, which is just 0. Okay. So then I get 1 over 20 x squared plus 1 over 100 x sine of 10x plus a 1 over 100 cosine of 10x. All right, and there we have it. Okay, so now we have our u1 and our u2. All right, so then our particular solution then, yp of x, right? Remember that has the form u1 of x times y1 of x plus u2 of x times y2 of x. Okay, so let's see what we get. If I plug in my u1, right, that is going to be 1 over 100 x cosine of 10x. Let's write that down. 1 over 100 x cosine of 10x. Okay. Minus 1 over 1,000 sine of 10x. Minus 1 over 1,000 sine of 10x. Okay. Times y1, which was cosine of 5x. Okay. Plus, now I'm going to have my u2 here. My u2 is 1 over 20 x squared plus 1 over 100 x sine of 10x. Okay, plus 1 over 100. Oh, sorry, this should be 1 over 1,000 there. Cosine of 10x. Okay. And then times my y2 of x, which is sine of 5x. All right. So now I can go ahead and distribute my terms a little bit here. So when I do that, I'm going to get a 1 over 100 x cosine of 10x times cosine of 5x minus a 1 over 1,000 sine of 10x cosine of 5x, okay, plus a 1 over 20 x squared sine of 5x, okay, plus 1 over 100 sine of 10x, oh, sorry, x times sine of 10x times sine of 5x, plus a 1 over 1,000 times cosine of 10x sine of 5x. All right, so in order to simplify this, all right, I see that I have cosines and sines of 5x's, and I see I have cosines and sines of 10x's. So I'm going to have to use a double angle identity here. Okay, so let's remember that. So I'll say recall, since I wrote them above, right? Sine of 2 theta is the same thing as 2 sine of theta times cosine of theta. Okay, and cosine of 2 theta is the same thing as 2 cosine squared of theta minus 1. Okay, so if I plug that in, right, and this is going to be 1 over 100 times x cosine of 10x, so that's cosine of 2 times 5x, right? That will be 2 cosine squared of 5x minus 1 times cosine of 5x. Okay, minus 1 over 1,000 sine of 10x. That would be the same thing as 2 times sine of 5x cosine of 5x. Okay, times cosine of 5x. And then we have plus 1 over 20 x squared sine of 5x. Okay. Plus 1 over 100 times x times sine of 10x. Remember, that's 2 sine of 5x cosine of 5x times sine of 5x. And then plus 1 over 1,000. I'll write it down here, actually. Give myself a little bit more space. Plus 1 over 1,000 times cosine of 10x is 2 cosine squared of 5x minus 1 times sine of 5x. Okay, so now I got to distribute this again, right? Simplify. So this will be 1 over 100 times x times, well, we have a 2 cosine cubed of 5x if I distribute that, right? So I'll write this as 1 over 50 x times cosine cubed of 5x, okay, minus a 1 over 100 x cosine of 5x. Okay, just distributing that. Okay, now for this term right over here, we get minus 1 over 1,000. Oh, so times 2. So I'll write this as 1 over 500. Okay, times sine of 5x times cosine squared of 5x. Okay, good. Now, right, down over here, I'm going to get plus 1 over 20 x squared sine of 5x. Nothing to do with that term. Over here, right, I'm going to simplify this a little bit. The 2 and the 1 over 100 are going to make a 1 over 50. So we get plus 1 over 50 times x times sine squared of 5x times cosine of 5x. Okay, good. And then our last term over there distributes into two different terms as well. So we're going to get plus 2 times 1,000. That's 1 over 500. Oh, okay, so that'll work just fine. 1 over 500 times cosine squared of 5x, right, times sine of 5x. And then minus 1 over 1,000 sine of 5x. Okay, so let's see if there's anything that cancels first of all. I have a 1 over 500 cosine squared of 5x sine of 5x, but I also have a minus 1 over 500 sine of 5x cosine squared of 5x. So that's going to cancel. That's good. Okay, anything else combined together? See, I have an x cosine of 5x term here. I have a sine of 5x term here. X squared, sorry, x there, x there. Okay, so let's see what else I can do then. How about I rearrange this a little bit. So I have 1 over 50 times x cosine cubed of 5x. Okay, and I'm going to kind of group that together with my other 1 over 50 term over here. Okay, so I'll say this is going to be a plus 1 over 50 x sine squared of 5x cosine of 5x. Okay, so I group those two terms together. Okay, and my other terms, I guess I'll leave them like they are. So I'm going to have minus 1 over 100 times x cosine of 5x. Okay, and I'll have plus 1 over 20 x squared sine of 5x. Okay, and then I'll have a minus 1 over 1,000 sine of 5x. Okay, all right. So having that then, now, now let's try this out. Okay, so my first two terms over there, right, this and this, I am going to rewrite this. I'm basically going to factor a cosine of 5x out. I'm going to factor a 1 out of 50 out of there. Okay. So I can factor out a 1 out of 50 cosine of 5x. And then what I'm going to be left with on the inside is, well, if I pull out one copy of cosine of 5x, I'll get a cosine squared of 5x here, plus a sine squared of 5x there. I forgot to factor out my x as well. So 1 over 50 x cosine of 5x. Okay. And then, of course, this is just 1, right? All right, this is just 1 right there. So then that's great. That's going to simplify dramatically then. Okay. All right, the other terms are still there. So I have minus 1 over 100 x cosine of 5x, okay, plus a 1 over 20 x squared sine of 5x, okay, minus a 1 over 1,000 sine of 5x, okay. And now let's see what we get, right, after simplifying that. So I have a 1 over 50 x cosine of 5x, okay, and I'm subtracting from that a 1 over 100 x cosine of 5x, okay? And then plus a 1 over 20 x squared sine of 5x, and then minus a 1 over 1,000 sine of 5x. Okay. So I have two x cosine of 5x terms, right? So really this is going to be the same thing as 2 over 100 minus 1 over 100, which is just positive 1 over 100 x cosine of 5x, okay? And then we're going to have, after that, a plus 1 over 20 x squared sine of 5x minus a 1 over 1,000 sine of 5x. Okay, let's pause here for a second. Okay, so that's my yp of x. All right, so then now my general solution is I take my homogeneous solution, c1 cosine of 5x, plus my c2 sine of 5x. And then I add on my particular solution, which is going to be plus 1 over 100 x cosine of 5x plus a 1 over 20 x squared sine of 5x minus a 1 over 1,000 sine of 5x. Okay, but then now sine of 5x is another homogeneous solution. So this minus a constant times sine of 5x, right? That's just going to get eaten by this. So I could really rephrase this as y of x is just going to equal to c1 cosine of 5x plus c2 sine of 5x plus 1 over 100 x cosine of 5x plus 1 over 20 x squared sine of 5x. All right, and that's my final answer. All right.